Welcome again. We're going to talk now about the mix modes, which is basically pressure control with a targeted tidal volume. So you're going to tell the ventilator, I would like this patient to receive 300. You deal with how much pressure you need to give. Okay? In this ventilator is called pressure regulated volume control, which is kind of a lie when you analyze the name. In other ventilators is called volume guarantee, BC plus, auto flow, you name it. Let's see how can we recognize, if we don't know the ventilator very much, how can we recognize this is a pressure control modality with a targeted tidal volume. So in the settings we're going to see a tidal volume, but when we look for the pulse time, ain't going to be there. That's telling you you're in pressure. Okay, so tidal volume, same thing. We're going to go for a protective strategy of 6 mL per kilo of ideal body weight. We're going to still do the same settings for respiratory rate, whatever PIP we need, FiO2, and then the I time will be the same as in pressure control. It will be the full time here. So we'll go with 1.2, and we're going to start. And when we start, we're going to see pretty quickly when the ventilator finds the pressure where it's happy that you're getting the 300 mL of tidal volume that we set up, that we have a square pressure time curve, same as pressure control. We have a decelerating flow time curve, same as pressure control, and we don't have a flat top on volume. This is a pressure control modality. If I wasn't to show you this, you will say this is pressure. Alright? And now, just analyzing what will happen when the situations change, we're just going to quickly give an obstruction to the patient, which in pressure control we saw that then it decreases the volume delivered. But here we are targeting the volume. Therefore, we provide the patient with obstruction. We go back to the vent. The ventilator realizes that we're not giving 300. We were given 200. So it starts increasing the target pressures, the pressures that it's generating. The pressures it's aiming to equalize. Up and up and up until it reaches the 300 that we were asking. The other things we are going to see are the same things that we saw earlier. The flow time curve, this inspiration doesn't reach 0. And the expiration in this case it does, because we are in low frequencies, but it wouldn't if we were in higher ones. Just as a sign of coincidence and just to make you aware, the ventilator now is pretty happy that it's reached 300 with 33 of pressure, so it's gonna stay there. But what did I say here earlier on? If you don't reach 0, you haven't equalized both systems. You have not reached totally the alveoli with the whole of your volume. So what's going to happen is the ventilator is going to deliver this 300 on the pressure. These 300 are going to come back, but a lot of it is going to remain only in the dead space and will not participate in gas exchange. So if you have particularly obstructive patients that you can see this is not reaching 0, don't be reassured by the volumes you're setting up and you're achieving here, because this might not be true. So if you then find the patient is hypoventilated, do not be surprised. And in these cases, you might need to go up in the target volumes to achieve the same result. If we now make the patient again not resistive but poorly compliant, same thing in our lung simulator. The ventilator has seen such a difference that this brand throws a volume control breath and then finds the alveolar pressure to adapt, and from there readjusts. Other ventilators, for example the Hamiltons, don't have volume control, so it will just increment the pressure, the target pressure up and up and up and up until it reaches the 300 it wants. So now we are playing with a peak of 29. The curves look pretty much the same, but this has gone up. Now the compliance improves. We open that up. The ventilator is still working at higher pressures. We get high volumes for a bit, 450, and then the ventilator tracks back again, because it's such a big difference that we've just done, throws a volume control breath, finds the alveolar pressure in the plateau pressure, and then targets that. And you see the big difference is now 20. So be mindful, in this ventilator there's like a contingency plan of activating a volume control breath, but some ventilators won't do that, they will just adapt up and down, so you will have a few breaths where you will be either over or under ventilating when the compliance or the resistance change. Thank you.